Hi everyone, so we are going to be doing Project Ghostbox. The idea to build the Ghostbox is pretty simple. We want to have a standard square enclosure. It's driven by the Raspberry Pi. We are going to want to have a camera, no IR. We are going to want to have a remote temperature sensor, which will let us detect the temperature of the wall and things around us. We're also going to want to have a built-in temperature sensor. This way we can detect if the unit's overheating. We are going to want to have some kind of microphone, which means we are also going to need to have some kind of speaker. This will allow people to take ghost voice recordings, EVPs, while they're working. We can try to capture them on camera. We can try to use temperature sensors to pick them up. Kind of trying to be an all-in-one unit. Now there's a couple other things we may want to add. We could put a EMF detector into the unit so it can check for electromagnetic frequencies. We also want to add on the back a touch screen, which will allow us to see a little bit better with the unit. And last but not least, we're also going to want to have a battery. One thing we want to consider is cases. As we go through, we'll figure out how we want to do the case, if we want to do a custom 3D print, or if we want to use a pre-made Raspberry Pi case. I have to caution before we get too far into this, Raspberry Pi is relatively new to me. Arduino I'm a little more comfortable with. So some of this we're going to have to figure out as we go along. The first thing I ordered is a Raspberry Pi. I went for the Model B, which comes with 512 megabytes of RAM, which means it can hold a little bit more in its memory. Not that we're going to really be using it, but the nice thing is, with more RAM you can reuse it later for more things. On the Raspberry Pi, you can see that this one has extra ports. It's very important with what we're trying to do to build a Ghostbox to keep it small. So even though we could add extension modules, things of that nature, we want to avoid that if we can. So I opted for one that has two USB ports. It's got an Ethernet port, which will be for internet. We're probably not going to use this later on. We also have, kicking around in the shop here somewhere, a little Wi-Fi module that's compatible with Unix. This also comes with a memory card. The memory card, well, it won't say on it, but it also has Noobs pre-installed, which is your landing part to kind of set up your Raspberry Pi for the first time. So I haven't gone through and used that before. This will be a first for me. But we needed a Raspberry Pi. We also needed a camera module. Now the camera module I got is made specifically for the Raspberry Pi. In fact, it has a special port on it for the camera modules. This camera module, as I mentioned earlier, is a no IR camera module. It's very tiny. The no IR is very important. So normally when the lights turn off we can't see anything because all of the visible light's out of the room. But most rooms still have a fair amount of IR. IR is infrared. It's another wavelength, if you will. And one of the advantages with viewing a room with IR still flooded, and that's why this has the IR filter removed, is it lets us see the room as if it's a little bit brighter. This will allow us to see things in the room that our normal eyes may not pick up. Now when we get there, it'll be interesting to see how the Raspberry Pi handles this. A lot of companies, especially camera companies, have a hard time handling the infrared spectrum because it doesn't have a color. So how do you mix that into color imagery without too much impact? And so some companies will set the IR band to just one color, they'll take the blue out of everything else, things like that. So it'll be interesting to see how it's built into the module. But we have one of those to play with. Now as well, we have a standard temperature sensor. This one is a temp 36. This will be on your device. So this will only pick up the temperature of what's in around the device. We're going to use that to find out if it's overheating. However, in my parts kit, I happen to have one of these little modules that you can also get from Newark. This is a no-contact thermometer. It uses IR to pick up temperature from something across the room. What we're going to do is we'll take that. We can't see where they're pointing with that, so we're going to need to add something that lets us see where that's looking. And what better than a laser? So we'll use a laser pointer to show us where that temperature sensor is pointing. Now back to the equipment we got. So this is going to be our temperature sensor and a laser to find it. We have an onboard temperature sensor. Some of the things we're going to want to build, which is probably things like a electrical sensor. We want to be able to adjust. So we've got some nice little trim pots which will allow us to adjust those things. When dealing with Arduino, I always deal with 10K. So I've assumed that it's going to be the same for the Raspberry Pi, but if not, I have some in my kit we can use. Now over here, these four are just LEDs. We'll use these for indicators on the unit, and of course, resistors. Now the resistors I picked up, I typically pick up 330 ohm. I just find that that's usually a good match with the LEDs. You want to check your specs and make sure when you order them. That's all stuff you want to figure out a little bit ahead of time. As well, we have some lights. So the problem with IR is that the room may not have IR. So it may not have a lot of infrared. So what we're going to do is flood these lights to cause infrared to fill the room, almost like a constant flash on the camera. Now, we also have a case. We may or may not use the case. If we want to create our own, we're going to use the 3D printer. We need something for the user to be able to see feedback on the unit. So if we want to see the camera feedback, I do have some Raspberry Pi parts. That one, here we go. So these parts we're going to make use of as well. These ones you could get from Newark. I already have them in stock, so there's no point in ordering them. And in here I have an Adafruit display. And this should be a touch display as well. And we can use this for feedback for the users. There's our headers, and there's our display, which is a little crooked at the moment, but there you go. So, headers, display. We may need some buttons. We're definitely going to need an on and off switch. So I happen to have a case full of buttons. Buttons you can get for cheap anywhere. I buy them in bulk. You can look on all kinds of places where they're cheap and affordable. I won't go through them here, but if you are picking them up in bulk, then Newark is just fine as well. In this case, I have so many switches and buttons and other doohickeys that it's not necessary. One thing I am going to take out of my kit is a light sensor. I'm not certain that we're going to need this, but chances are we're going to want to be able to detect how bright it is in the room. We also want to be able to hear if there's a ghost in the room for sounds that we may not pick up. So we're going to need one of these as well, which we can use to plug into the Raspberry Pi. In part 1, we will do the speaker and Pi setup. So I've cut 2 pieces of wire. These are 22 gauge, which is a little bit bigger. I chose to go with solid instead of strand, which is a little abnormal. Usually you use stranded wire when you're working with anything that you're soldering. It just sticks better to solder. But the nice thing about these solid wires is they keep their shape really well. In this case, we're still prototyping. I'm still making it up as we go. This is just a preference for me. So I used the wire strippers to cut off the ends on the cable, and we took the wires off of the 2 ends on here. So what we're going to do, clean that up first, put a nice amount of solder right on it. Make sure you get it all over. I always do that before and after soldering. It helps keep the tip nice and clean, and tips are more expensive than you might think. So now, because there's already solder on here, we're actually kind of lucky. You should be able to get it to stick. There we go. And make sure it's nice and firmly on there. There we are. Now I'm going to add it to this. There's usually 2 points, one here and one here. I'm going to go ahead and do that point first. So what I do is make a little hook it through that little eye hole, bend it back. So once the files have finished copying, we can go ahead, right click on our package. Okay, now while I'm here, I'm going to go ahead and loop that one through, pull that up, and pull that back. Our SD card is ready to be loaded. There we go. And tighten that little connector. There we are. Now we got to actually solder that so it stays. Over. Good. Solder it down. there we go. Now created our own little power speaker. Didn't think that through, did I? Well, that'll teach me to rush. But easy enough to fix. And in fact, while we're doing this, let's go ahead and use a piece of heat shrink tubing. Certainly not necessary. But let's clean up the cables while we're here. There we go. Now you're supposed to use certain types of tools for this. In this case, believe it or not, going really quickly over and over again with your soldering iron will work just fine. And it will tighten it right up. So there we go. Now I used the gunky end first, so there we are. Now let's attach those ends. First things first, I'm going to make the ends the same length. Going to number 4. Get that done. Now I'm going to solder that on. Now I have lots of solder on here. Let's see if it'll stick and stick well without new solder. This is technically bad practice, so don't do it this way at home. So there we go. We've now created our own little speaker. We're now ready to go ahead and get our SD card ready for Raspberry Pi. You'll notice that most Windows operating systems these days, when you plug in your SD card, it will pop up and show us that the drive is empty. Unfortunately, this card will probably still be in the incorrect format, so for safety we're going to go ahead and format it first. The website we're going to do the formatting from is sdcard.org. We're going to go to Downloads, SD Card Formatter 4.0. In this case, we're going to go to the Windows download. It's going to walk you through the end user license. Go ahead and hit I accept. You'll see that it's ready to download. Just go ahead and hit OK. Now in my case, I've already downloaded it. Somewhere in here. So we'll go ahead and double click on it. In there you'll see the setup package. Let's go ahead and run it. It's going to go ahead and do its installation. Now when installing any of these programs you want to watch carefully. This one I think was safe, but some of them will try to install pop-ups. We'll go ahead and treat it like a fresh install. Once you hit install, it's going to go through, do its thing, and you just hit finish. Now in here, we're going to do a search for the term SD format, and you'll see SD formatter. Run that program, and there you go. Make sure the drive is set correctly. Go into options, change format size adjustment to on, and press OK. Now just press format. It's going to give you a warning, say yes. It's going to say do not remove the drive, say yes, and done. So we've now finished the setup. Next stage is to put the actual software on there. So we come back, this time we're going to go to raspberrypi.org/downloads. What we can do is either download a torrent, which I ended up using and it went much faster, or you can download the zip file. What I found was the zip file went about 250 kilobytes per second, whereas the download went over 3 megs per second and seemed to go strong. I'll also put a download from one of my websites on here, just to make the package more accessible. It'll act as a zip, but it'll give you a little bit more speed, probably in around the 1 megabyte per second. Now I've gone ahead and already downloaded Noobs, and it's sitting right here. Now I chose to get the non-light version because my current Raspberry Pi is not set up with the internet. In here, we're going to go ahead and double click on Noobs, and you're going to see a whole bunch of files. We're going to press Control A to select all, Control C to copy, go down to our new drive and press Control V. Okay, we're ready to set up the Raspberry Pi. We need our T, very important. We need our Raspberry Pi, a memory module, otherwise it's not going to do a whole lot. Keyboard and mouse. I don't know if this mouse is going to work. It's not the world's greatest mouse, but I love it. It's cheap and it's simple. And a video cable. We want to make sure that these silver gold looking things are facing towards the inside of the card. Okay. We're also going to need some kind of video connector. We are going to need a keyboard and a mouse. Okay, we're also going to connect our camera module. Now in this case, you will notice that there are connectors along the bottom of this strand. What we're going to do push that up until it's nice and loose. This end goes gold strip or silver strip towards you. Keep it in there nice and firm and connect it in. You'll know it's good if with a little bit of tension it still stays in place. Okay. Now we're going to take that same cable and plug it into the bottom of our TV. Okay. Now before we go any further, it's not going to work, quite obviously because we never connected power. So in this case, I have a nice cable that looks like it's going to fit perfectly into what looks like the mini USB port, but it's actually micro. Now we're just going to plug this in. We have a light that's come on. That's a good sign. I'm going to go ahead and show you the monitor. This needs to go on to HDMI 2. Verdict is, looks like an operating system to me. Try to get you a better view. You can see the very first question it's asking me is, what operating system do I want to put on here? We've got a bunch of different choices. There is Arch Linux. One of the nice things about Arch Linux is there's actually a fair amount of programs out there for it that I've seen. There's some really good emulation, like Arch Retro, which is a wrapper. It takes a whole bunch of emulators, puts it in one. Great for a gaming system, not really what I'm looking for on here. We also have a version of Debian, which is always safe. A Fedora remix. So if you're an Xbox Media Connect, which ironically has nothing to do with Xbox anymore, boots it straight into Scratch. So I've got a bunch of different choices. Now, this is really going to depend on the individual. You can look it up and see what's recommended as the best one. I'm going to go with Debian. Simply because I've used it before, I've used it in a commercial environment, supporting it, I'll be a little more comfortable. So, oh, looks like the mouse does work. I'm going to go ahead and press install. Warning, this will install all the existing data on the blah 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 blah. I'm assuming it's going to wipe out nukes. With that said, these days most people have a decent internet connection. If you need to reinstall it, you'll reinstall it. Okay, we've now successfully completed the installation. We hit enter. It should reboot and come up. Alright, configuration tool. You folks probably can't see that. Change the password for the default user. Let's go ahead. And down in the bottom corner, it's asking me to enter a password. Password is successfully entered. Go ahead and hit enter. We're also going to go and pick option number 3. Let us go with, let's do graphical for now. Keep in mind, we are planning on using a touchscreen for this environment, which means you kind of want to have a touchscreen GUI. We're going to enable camera. And we're finished. Hit enter. Would you like to reboot? Let's do it. So now compared to Arduino, where we would have had to have pretty much done a lot of that work ourselves to get a camera to work, it's now going to work right at the operating system level for us. And there we go. One fancy little operating system. We have a successful boot from Pi.